Okay, let's dive right in. Today, we're doing more than just analyzing the AI hardware market. What we're doing is presenting an investment thesis, and it's built on what we call a distinct variant perception. The consensus view out there is pretty simple. Nvidia owns the world. But we're here to argue that the most undervalued battleground, the real fight, isn't happening in the cloud. It's on your device, in the edge AI space. And that's where Apple's unique architecture gives it this powerful and, frankly, widely misunderstood competitive moat. So, here's how we're going to break this down. First, we'll establish our core variant perception. Then, we're going to do a deep dive into Apple's key technical advantage, what we're calling its unified memory moat. After that, we'll stress test this whole idea against the biggest threat out there, Windows on ARM. Then, we'll get into the nitty-gritty of the economics, the true cost of running AI on device. And finally, we'll pull it all together into the endgame and define who wins the battle for personal intelligence. All right, so let's start with our core thesis. While everyone is screaming, Nvidia owns the world, we think the market is completely missing the real story here. The most important AI hardware battle isn't actually happening in some far-off data center. It's happening right here, on the edge. And you have to understand, on the edge, the rules of the game are totally, completely different. Look, as an investor, if you want to find any real alpha in this space, you have to move past that Nvidia owns the world consensus. Real analysis means looking beyond the obvious, beyond their dominance in the data center to figure out where the next wave of value is actually going to be created.
And just so we're all on the same page, when we say variant perception, we're talking about an investment thesis that flies directly in the face of what the market believes. It's all about finding an opportunity that is either misunderstood or just flat out undervalued. And that, right there, is exactly what we see in Apple's position in Edge AI.
So, this brings us to the first pillar of our evidence, Apple's unified memory moat. Right now, the market is obsessed with one thing, raw compute power, measured in TOPS, trillions of operations per second. We're arguing that's the wrong metric to be looking at. The real bottleneck for running these huge language models locally isn't compute, it's memory bandwidth. And this slide really shows you why. It's a fundamental architectural difference. In a traditional PC, the CPU and GPU, they have their own separate little pools of memory. So to do any AI work, you're constantly shuffling massive amounts of data back and forth, which creates this huge latency tax. But Apple Silicon's unified memory architecture, UMA, it just gets rid of that problem entirely. The CPU, GPU, and the neural engine all share one single super high bandwidth pool of memory. This means zero copy access. But here's the real advantage. While a PC is stuck with a tiny, expensive 8 to 24 gigabytes of VRAM, a Mac can use its entire system RAM. We're talking up to 192 gigs or even more to run a model. It's not even in the same league. It's a completely different class of capability. And the scale of this advantage is just massive. The projected memory bandwidth for the M5 Ultra chip is over 800 gigabytes per second. Now, to put that in perspective, that's the kind of performance you'd see in high-end, dedicated Nvidia data center GPUs. But the difference is, on a Mac, it's available for the entire system, on a device you can buy in a store. So, what does this actually mean in the real world? Well, take a look at these examples. A 70 billion parameter Llama model, it runs smoothly on a Mac Studio. That same task is it's impossible on a single consumer GPU because of its VRAM limits. And even more impressive, a gigantic model like DeepSeek, when you quantize it, sort of compress it for efficiency, at 671 billion parameters, well, it can run on an M3 Ultra. To do that on a PC would require multiple high-end GPUs and would burn through nearly 10 times the power. Now, of course, no investment thesis is worth anything unless you really stress test it against the competition. And that brings us to the number one risk, the very real threat coming from Windows on ARM. Let's break down who the key challengers are. First up, you've got Qualcomm. The risk here is high, and here's why. Their Snapdragon X2's Elite paired with Microsoft's big Copilot Plus push is the first credible threat to Apple's leadership in performance per watt. Then there's Nvidia. We're calling this a medium to high risk. If they can figure out how to bring a mini version of CUDA to a consumer chip, they could totally capture the pro developer market. And finally, you have AMD, a medium risk. Their Strix Halo chips are coming with up to 128 gigs of unified memory, directly challenging Apple's high memory advantage. But let's be crystal clear. The single biggest threat on the horizon is that Qualcomm-Microsoft Copilot partnership. For the very first time, this alliance presents a genuine, credible challenge to Apple's historic dominance in the battery life to performance ratio for ARM laptops. This is the one you really have to watch. So Apple's technical advantage is pretty clear, right? But it's the economic argument that really cements its moat. And this is the third pillar of our thesis, the true cost of inference. This is where the economics of running AI on the edge versus the cloud get completely flipped on their head. This total cost of ownership comparison really frames the whole argument. With on-premise hardware like a Mac Studio, yeah, you have a high upfront capital expense, but your operational costs are predictable. The cloud, on the other hand, offers zero upfront cost, but your costs are variable and they just scale and scale with use. But where the analysis really gets deep is when you factor in the hidden costs of the cloud. Things like data egress fees, what it costs to get your own data out, and all the complexities around privacy. With an on-device model, you have zero egress fees and absolute privacy. It's a game changer. And here is the financial punchline. For any kind of high utilization workload, think of a small company running its own internal AI agent 24/7, the break-even point for buying that hardware versus renting a cloud GPU is less than 4 months. After that, you are basically running AI for just the cost of electricity. The unit economics, the token economics, make this even more obvious. To generate 1 million tokens, it costs about 11 cents on your own hardware. On a cloud instance, that jumps to 89 cents. And if you go through a proprietary API, it could be $2. The key takeaway is simple. Self-hosting gives you a staggering 8 to 18 times cost advantage. That's a huge economic incentive pushing more and more workloads to the edge. So, how do we tie all of this together? The tech, the competition, the economics, well, it all leads to what we call the personal intelligence endgame. And it answers that one critical question. Who is ultimately going to win the battle for the edge? We believe there are actually two distinct battlefields in edge AI. First, there's the enterprise edge, industrial robotics, fleet management, large-scale IoT. This is a world where scale and interoperability are everything, and we see Nvidia and Qualcomm winning there. But the second battlefield is personal intelligence. This is the consumer edge, where AI acts as your own personal agent. And here, the winning attributes are totally different. It's privacy, low latency, and user trust. In this segment, the winner is going to be Apple.
And this is what we define as the behavioral edge. This is Apple's ultimate moat. It's not just built on silicon, it's built on user psychology, something investors almost always underestimate. Privacy is everything. People will not send their sensitive financial or medical data to some random server. Latency matters. You need answers instantly. Resilience is critical. Your agent has to work even when you're offline. And all of it, builds trust. Users are just far more willing to give deep access to their personal data to an agent running on their own device than they are to some remote faceless server.
And that really brings us to the core question of our entire thesis. As AI stops being just a simple tool and becomes a true personal agent, who do you fundamentally trust with your most sensitive data? Some remote server owned by a giant corporation, or the device that you hold in your hand?